Okay, well, the first thing we're going to do to kind of just review is we're going to look at finding moles. And this is something we've done a lot of in here at different times. And so when you go A, B, and C, they progressively get a little bit tougher, not too bad. So on the first one, if you notice we have 10 grams, and we've got to change that into moles of sodium. So when you look on your periodic table, each of the elements, if you remember, has a weight that represents the number of moles, which is the same number for everything. And like if you look up sodium, it's 22.98. And that's how many grams are in a mole for sodium. So what we do is we want to change this 10 grams into moles. We take 10 grams of our sample, and our conversion ratio is right here. But we got to make sure the units are in the right spot. So if you notice this says grams of sodium, then that grams of sodium need to be down here so that they can cancel out. Up here needs to be moles. So that would be 1, because up here, that's 1. And down here would be 22.98. So when you do the calculation of that, that will give your answer. And when you take 10 divided by 22.98, since it's on bottom, you get an answer of 0.435 moles of sodium. That's moles of sodium. Next one gets a little bit tougher because we got two elements bonded together. So I'm going to go ahead and erase this. We'll start with the second one. And it says we have 25 grams of NaCl. We've got to go from grams of NaCl to moles, just like we did on the sodium. Here's a problem. We can't just look at the periodic table and just pick it off the periodic table. So what we have to do is split this apart into sodium and chlorine. And we've got 1 each. So that'd be times 22.98. And then this would be 35.45. Then we add those together. And we get 58.43. That goes in here. To 1 mole of chlorine, sodium chloride. So then when we divide that out, then that'll give us our correct number of moles of sodium chloride. Okay, and so that's 0.43. Okay, so that's only 2 I think I need to show you. Letter C, you would do the same as B, but this one, you know, you have 3 oxygens, so you'd have to multiply oxygen by 3, carbon by 1, calcium by 1. When you do that, then that gets your molar mass, and then you would do the same thing with what you did here. Now, when we take a look at a way to measure concentration is molarity. The past worksheet, Thursday, we did things with percent by mass, percent by volume, parts per million. And these are all based upon volume and mass ratios. In chemistry, we're interested in reactions, which would be number of moles or molecules in a reaction, like we've done in the past. So, knowing that, we've got to do some things with solutions, and we got to know their concentrations. what we're going to do is we're going to go ahead and use this equation, molarity. Now an easy way to show molarity is the capital M, and that equals moles, and I just shorten it up, over liters. So if I can find moles of my solute, and I can find liters of the solution, then I just have to take moles divided by liters. So this one's really easy. As you can see, you take the 0.25 moles divided by the liters, and that gives me molarity, which is moles over liters. So this one would give me 0.5 molarity. Okay, so 0.2 divided by 0.5 would give me 0.5 molarity. That's the strength of that solution in moles per liter, which is a little bit different than mass, quite a bit different. Okay, we progressively get a little bit more difficult. This one has milliliters, and if you notice, molarity is equal to moles over liters. Well, this is milliliters. We can't leave it in that, so we'll just take 250 milliliters and get it into liters. And we know there's 1,000 milliliters in 1 liter. So that gives us 0.25 liters. So we would take the 0.5 moles divided by 0.25 liters, and then that gives us our answer, molarity of KNO3. So our answer is 2 moles over liters. So again, just recapping it, we got the 0.5. That one's, we don't have to do anything with that. The 250, we just change it into liters, which is 0.25, and we divide it out. Pretty simple. Next one is, I think, more difficult. Okay? You notice on this one, we have 4.55 grams of NGF2. Well, we have volume that will go right into our moles over liters. That would be 0.75 liters. That would equal molarity. So if you notice, this is grams, and this requires moles, and that's not the same. So we're going to have to convert this number here, 62.3. We'll go down here. And gets our moles. So on this one, we have to convert to moles so that we can plug it in up here, because this one wouldn't work if we just use grams. Okay. So then we take the 4.55 divided by 62.3. We get 0.073. That goes up here. So then that would be divided by 0.75. And then our value that we get out is 0.97 molarity. I can use capital M too. Prior ones I just put moles over liters. Okay. Last one that you got to concern yourself with is the toughest one. So again, we want moles over liters. So if you notice, there's 200 milliliters. So this is like B. You take the 200 milliliters and you change it to liters. And that gives you 0.2 liters. Well, that goes down here. The moles, you have grams of KCl. So we got 1 K and 1 Cl, and that's 39.1. We're going to round it. And then this is 35.5. We'll round that one too, make it quick and easy. So this would be 39.1, and this is 35.5. Add them up. You get 74.6 grams per mole. So we're still not there, but we're right there. We can take this 2.5 grams and change it into moles. So what we could do is take that 2.5 grams and convert it into moles. Grams of Ki go down here, my conversion ratio. Moles of Ki go up here. Down there, 74.6 grams to 1 mole. And then I would have my answer. 0.0335, I guess that's my final answer because I'm going to have to plug that in. Over here. And then that gives me my molarity. And it's 0.17 molarity of KCl. So your worksheet that you have, we went 1 through 8 yesterday, and we did percent by mass, percent by volume, and parts per million. 9, 10, 11, 12, 13, or 9 through 13 deals with these problems I just went through with you. So if you would go ahead and work those, and then we can check our answers and kind of go from there.